This lesson introduces quadratic equations and how they are related to quadratic functions. In a previous lesson, you learned a quadratic function is defined by second-degree polynomial equation, y equal ax squared plus bx plus c. The graph of a quadratic function is a smooth, symmetric, arc-shaped curve called a parabola. The line that divides the parabola in half is the axis of symmetry. The point where the axis of symmetry intersects the parabola is the vertex. If you start with the quadratic function and set y equal to 0 and turn it around, you get the quadratic equation. Ax squared plus bx plus c equals 0 is the standard form of a quadratic equation. This lesson and the following lessons help you understand quadratic equations and how to solve them. You graphed this quadratic function in a previous lesson. The related quadratic equation is negative x squared minus 2x plus 3 equal to 0. If you substitute x equal 1, you get negative 1 squared minus 2 times 1 plus 3. Negative 1 squared equals negative 1, and negative 2 times 1 equals negative 2. Then negative 1 minus 2 equals negative 3. And you have negative 3 plus 3 equal to 0, which is a true statement. So x equal 1 is the solution to the equation because it's a value of the variable that makes the equation true. If you substitute x equals negative 3, you get negative 3 squared minus 2 times negative 3 plus 3. Negative 3 squared equals negative 9, and negative 2 times negative 3 equals positive 6. Then 6 plus 3 equals 9, and you have negative 9 plus 9 equal to 0, which is a true statement. So x equals negative 3 is also a solution. So here's the quadratic function, its related quadratic equation, and the solutions to the equation. Notice the solutions are equal to the x-intercepts of the function. One of the solutions is x equal 1, which matches the intercept at 1 on the x-axis. The other solution is x equal negative 3, which matches the intercept at negative 3 on the x-axis. It's easy to understand why this is true. The solution to the equation is a value of x that makes the expression equal to 0. Since this expression is the function, a solution is the value of x that makes the function equal to 0. And the function is equal to 0 at its x-intercepts. Notice the y-coordinates of the intercepts are 0. So the solutions and the x-intercepts are the same. And this is true for all quadratic equations. The relationship between the solutions to the equation and the x-intercepts of the function also tells you something important about the number of solutions of a quadratic equation. The vertex of a quadratic function is located in one of three places. It can be below the x-axis, it can be on the x-axis, or it can be above the x-axis. So if the graph of the function opens upward, The function can have two x-intercepts, one x-intercept, or none. Therefore, since the intercepts and the solutions are the same, when you're solving a quadratic equation, you can expect to have two solutions, one solution, or none. This lesson is brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.